الله الرحمن الرحيم. This topic, which is the relative maximum and relative minimum. We say that the relative maximum or the relative minimum is the highest value of the function in a small interval or small part of the domain, small neighborhood of the domain. And we gave different type of example. And to find the relative minimum or relative maximum for a function, we have two steps. Step number one, we need to find the critical points. Step number two, we need to test the sign either for the first derivative or the second derivative test. We can apply the first derivative test or the second derivative test. Now to complete this topic, we are going to finish it with this example now. I need to find the point of relative maximum or relative minimum of the curve f of x equal to absolute value of x squared minus 2x minus 24. Find the relative minimum or relative maximum. In general, we know that the function of x equal to x squared minus 2x minus 24, this is parabola. And for the parabola of this type, we need to find the y-intercept of the function. Y-intercept. Or I'm sorry, x-intercept, not y, x-intercept. This function x can be, or x squared minus 2x minus 24 can be written as x minus 6 multiplied by x plus 4 equal to 0. This is to find x-intercept. We will have x equal to x or x equal to minus 4. Means that if I want to graph this function at x equal to minus 4 and at x equal to 6, we have x-intercept. And since the sign of x squared is positive, the parabola will be upward. This is the graph of this function, x squared minus 2x minus 24. But in our example, we have absolute value, which means that any negative part will be reversed. It will be above the x-axis, above the x-axis. I will not have any negative part in this function because of the absolute value. So this part which is negative will be up. So this is the graph of the absolute value of this function. It is very clear that we have relative minimum at this point, minus 4 and 6, and one relative maximum somewhere between these 2 points. So I will have 3 critical points. The first one is minus 4, and the second one is 6. These are the definition points of the absolute value. Because we know that to remove the absolute value from the function, we have to find the x-intercept and check whether it is positive or negative between or outside these points, to the left or to the right of them. So the function f of x is equal to absolute value of x squared minus 2x minus 24 is equal to, it is positive greater than 6, positive less than minus 4, and negative in between. So I have x less than or equal to minus 4 we have minus 4 less than x less than 6, or I can take it just, and I have x greater than 6. These are the definition points, the points where the function is equal to 0, or just simply I can say it is x-intercepts. Now, if x is less than minus 4, I will have positive. We can take that one. So it will be x squared minus 2x minus 24. This is if you want to remove the absolute value. So it is positive. Between minus 4 and 6, it is negative. It is x squared minus 2x minus 24. And it is negative, so I need to multiply by negative to make it positive. So it is plus if x is less than minus 4, negative if it is between minus 4 and 6, and it is positive if it is greater than 6. And it is positive sign. Now, let's differentiate the derivative for this function f prime is equal to the first derivative, it is a plus, then differentiate, it is 2x minus 2. This is x less than minus 4. For the derivative, we are looking for the open interval. Second one, it is negative, and then differentiate 2x minus 2. And minus 4 less than x less than 6. And last one, when x greater than 6, it is positive 2x minus 4, minus 2. This is if x greater than 6. Now to find the critical point for the derivative, f prime of x equal to 0. In all of these, I will have x equal to 1. I have that x equal to 1. If I make this equal to 0, I will have x equal to 1. If this is equal to 0, I will get x equal to 1. If this is equal to 0, also I will get x equal to 1. So when the derivative is equal to 0, I will have x equal to 1. Which means now the critical points are minus 4, 1, and 6. This is from the derivative, and these are, because the function is not differentiable, I have corners because of the absolute value. Points of the definition of the absolute value are non-differentiable point, or the function is not differentiable at this point. The function is not differentiable at the definition point of the absolute value function. So I have minus 4, 1, and 6. Now we need to test the sign. Check the sign. I have 3 critical points. Minus 4, 1, and we have 6. Choose values for testing the sign. I will take minus 5 in this interval. Between minus 4 and 1, we can take 0. Between 1 and 6, we can take 3, and greater than 6, we can take 7. These are just testing numbers for the derivative. Now for the first one, minus 5. Minus 5 is less than minus 4, so we are in this part. Replace x by minus 5 in the first part of the function. It is 2x minus 2 is minus 12. So for minus 5, f prime of minus 5 is equal to 2 multiplied by minus 5 minus 2, it is negative. It is minus 12, so I will have negative sign. Now for the 0, f prime of 0. 0 is in the second part. It is between minus 4 and 6. So replace x by 0 and this one minus 2x minus 2. I will have this is minus 0 minus 2. It is positive. Sorry. It is in this area. This interval. It is positive. So the derivative will be positive between minus 4 and 1. Now if we choose 3, f prime 3, again, this is in the second part between minus 4 and 6. Replace x by 3, it is 2x, 6 minus 2 is 4, and negative sign outside, I will have negative, so this is negative. For x equal to 7, last one, greater than 6, so we are in the last part. Replace x by 7, 2 multiplied by 7, 14 minus 2 is 12, which is be positive, that will be positive. So the derivative now is going down in the interval minus 4, then going up because it's positive, the derivative. Again, going down between 1 and 6 and up greater than 6. So you can see it is taking this shape. So at x equal to minus 4 and 6, the function has relative minimum. Now this will give me f has relative minimum at equal to minus 4 and 6. The function has relative minimum at x equal to minus 4 and x equal to 6, and a relative maximum at x equal to 1. This is the idea of the absolute value function. First step, you have to find the redefinition point or redefining point that are in this example minus 4 and 6. Then remove the absolute value, find the critical value, critical point from the derivative, then test the sign of the derivative. You will have minus 4 and 6, these are relative minimum, and at x equal to 1 we will have relative maximum.